So, back in January 2022, there was this Indian food delivery company, right? And they looked at a moving train schedule and basically decided, hey, we can perfectly time the delivery of a hot meal to literally seat 14B right as the train rolls through the station.
Which is just, I mean, it's an insane logistical flex.
Right. Like, they actually partnered with the Indian Railway Catering and Tourism Corporation to make it happen. And today we are looking at the digital blueprint of how they pulled that off. Because the global online food delivery market that we are examining today, it's projected to hit a staggering $1.92 trillion by 2029.
Yeah, trillion with a T. It really forces you to reevaluate what local commerce even means anymore. Because, delivering to a stationary house is one thing, but hitting a moving target on a massive railway network, that requires a level of logistical coordination that honestly used to be reserved for the military.
It totally does. And that is exactly what we're going to unpack today. So this deep dive is for you, whether you are, an aspiring entrepreneur trying to understand market entry, maybe a tech enthusiast curious about the architecture of modern convenience, or just someone wondering how the apps on your phone actually coordinate your late night takeout.
Because it's not magic, even though it feels like it sometimes.
Exactly. Our mission today is to explore the mechanics behind building a food delivery empire, literally overnight, using a strategy the tech world calls a Swiggy clone app.
Okay, let's unpack this.
Yep.
Because we are talking about a $1 trillion market size down to this very specific, actionable concept of a white label clone app.
Yeah, which can sound a bit like, I don't know, science fiction, or maybe a little legally dubious at first glance, but it is actually a highly structured, very accessible business model.
But to understand it, we probably need to look at the original source material first, right? Like, what actually is Swiggy? Right, yeah. So Swiggy is an absolute behemoth in the Indian market. They launched back in 2014 under the name Bundle, and today they operate in over 500 cities.
Wow, 500.
Yeah, it's massive. They are the primary digital bridge for global giants. McDonald's, Pizza Hut, Burger King across India.
Right, and they are constantly pushing the logistical boundaries, like testing those drone deliveries we read about alongside the railway partnership.
Yeah, the drone testing in January 2022 was a huge signal to the market.
So if you were looking at this $1.92 trillion pie and you're thinking, okay, I want a slice, the obvious hurdle is infrastructure. Like, how could a startup or even just a mid-sized local business ever hope to compete with a company that is out there testing delivery drones? I mean, you can't just sit down and write a million lines of code to catch up.
You really can't. And that is where the clone app concept comes into play. So a Swiggy clone app is essentially a white label, ready-made food ordering and delivery software script.
Ready-made meaning like it's already built.
Completely. It is a fully customizable ecosystem that allows a business to just bypass years of initial software development. Instead of building from scratch, you purchase this framework and, hypothetically, you can launch a functional food delivery platform in about 14 days.
14 days. That is wild. I was actually trying to conceptualize this while reading through the sources, and it feels a lot like residential construction.
Oh, how so?
Well, instead of hiring an architect to design a custom house and pouring the foundation, framing the walls, routing all the plumbing yourself, you are basically buying a prefabricated digital house.
Oh, yeah, that's a great way to put it.
Right. Like the layout is already optimized for how humans actually live. The plumbing, meaning the payment gateways and GPS tracking, is already connected and pressure tested. You basically just paint the walls in your brand colors, upload your local menus, and put your name on the door.
That is a highly accurate way to look at it, actually, especially regarding the underlying structure, which relies on what they call a hyperlocal delivery model.
Hyperlocal, meaning they aren't using those massive warehouses.
Exactly. You aren't building centralized Amazon-style fulfillment centers. The software simply provides geographic matchmaking.
Okay, so it just connects the dots.
Right. It identifies a user in a specific neighborhood and connects them instantly with the inventory of a restaurant maybe 3 blocks away. And then it dispatches a driver who just happens to be in that same 2-mile radius.
Okay, but I have to bring up the elephant in the room here, because when I hear the word clone, my immediate thought is just straight up intellectual property theft.
Sure, yeah, that's the natural assumption.
If you are buying a copy of Swiggy's highly successful model, how are you not immediately hit with a massive lawsuit?
Well, the legal framework surrounding software development handles this in a very specific way. Cloning an app, at least in this context, is not illegal. provided you aren't violating copyrights, stealing proprietary source code, or infringing on their trademarks.
So you aren't literally hacking Swiggy's servers to steal their specific code.
No, not at all. What's fascinating here is that these clones aren't exact replicas of Swiggy's massive network.
Yeah.
You are replicating their behavioral workflow.
You're copying the psychology of the transaction, essentially.
Yes, exactly. I mean, the sequence of selecting an item, adding it to a cart, tracking a driver on a map, these are established generic mechanics of e-commerce now. You are licensing a new, independently written piece of software that mimics that highly effective sequence, but you're applying it to your own proprietary business network.
Okay, I get it. So you legally acquire this prefabricated digital house, but, a house doesn't generate revenue. How does this clone app actually pull cash out of a neighborhood?
Right, the monetization.
Yeah, because the user journey itself is pretty familiar to all of us. You download the app, it locks onto your GPS, you search for, I don't know, spicy tuna roll, pay through a digital wallet, and watch a little car icon drive to your house.
Right.
But the economics behind that seamless experience, reading the sources, they're surprisingly complex.
They have to be, honestly, because the platform operates in a super low-margin, high-volume environment. The revenue streams are highly diversified.
Break those down for us.
Sure. So there is the standard delivery fee, which the app calculates dynamically based on distance or time of day. Then there are platform service fees attached to the customer's bill, basically to cover server costs.
Makes sense.
And if the app features its own digital wallet, the platform actually earns interest on the funds users preload, or they take a micro percentage of every wallet transaction.
Oh, wow. And the sources also mentioned subscription models, right? Where users pay a flat monthly rate for $0 delivery fees, locking them into using your app over a competitor's.
Exactly, the loyalty play.
Plus, there is advertising revenue, where restaurants pay a premium to rank at the top of the search results when someone types in pizza.
Yeah, and all of those are vital. But they're essentially supplemental. The absolute heavyweight of the revenue model, like the core engine keeping the app alive, is the restaurant commission. The platform typically takes anywhere from 10% to 30% of the total order value directly from the restaurant.
This is where I stop and really had to think about the causality of the business model.
Wow.
Because if I am running a local mom-and-pop diner, my profit margins are famously razor thin.
Oh, incredibly thin.
Giving up 30% of top-line revenue sounds like financial suicide. So why did they do it? And reading through the data, it hits you. They aren't paying for delivery. They are paying for customer acquisition.
That is the fundamental paradigm shift right there. A local restaurant, they just don't have a massive marketing budget.
Right.
They rely on foot traffic and word of mouth. By giving up that 30%, they are buying access to a centralized pool of thousands of active users that they could never reach independently.
They are essentially renting storefront space on the busiest digital street in the city.
Yes.
And the volume of new orders they get by simply being visible on the app, that is supposed to mathematically offset the percentage they lose on each individual dish.
Precisely. The app is selling visibility to the merchant and convenience to the consumer. But, executing that transaction, taking that 30% margin, routing a driver, pinging a kitchen, and splitting the payment instantly, that requires absolute technical perfection.
Because if the app crashes...
If the platform crashes on a Friday night, the entire economic ecosystem collapses. Nobody gets paid, nobody gets fed.
Which brings us to the actual architecture of the software. Because going through the sources, calling it a food delivery app is a total misnomer.
It really is.
The sources reveal that you aren't buying one app. It's actually a four-headed beast. You are managing an incredibly volatile system, and the technology operates a lot less like a single piece of software and much more like an air traffic control tower. You have all these different moving parts that have to communicate in real time to avoid a collision.
Yeah, the complexity is hidden by design. But yes, a comprehensive clone script includes 4 distinct interfaces.
Okay, what's the first one?
The first is the customer app. This is the front-facing storefront. The engineering priority here is minimizing friction. It requires advanced search filters, push notifications for engagement, multiple integrated payment gateways, and of course that real-time GPS tracking interface. It has to feel completely effortless.
Right, that's the passenger in our air traffic control metaphor. They just want a smooth flight.
Exactly.
But then you have the second piece, which is the restaurant app, and this is what sits on a tablet in the middle of a hot, chaotic kitchen.
And its primary function is order management. The kitchen staff uses this to acknowledge an incoming order, update its status to preparing, and finally mark it ready for pickup. But there is a crucial, often overlooked feature here called status availability.
I found this fascinating because if a restaurant gets totally slammed at 7 p.m. on a Friday, or if they suddenly just run out of pizza dough, they can use this app to temporarily toggle their status offline.
Right, they could just pause the influx.
If they couldn't do that, if the app just blindly kept feeding them orders, the kitchen would crash, deliveries would be 2 hours late, and the restaurant's public rating would just be permanently destroyed. The app actively has to protect the restaurant from its own digital success.
Yeah, it acts as an operational pressure valve. It's vital. Now, the third interface is the Rider app, which is designed specifically for the delivery fleet.
The drivers.
Right. Obviously, it relies heavily on location tracking so the platform can assign the closest available driver and so the customer can watch their progress. But an equally vital feature of the Rider app is the autonomy it provides. Riders must have the ability to accept or decline incoming delivery requests.
Which is absolutely essential for the economics of the driver. Because if the app tries to force a driver to take an order that requires driving, I don't know, 5 miles away from the busy downtown center, only to drop off a single coffee.
They lose money.
Exactly. They lose money on gas and time. Declining an order isn't a glitch in the system, it is an efficiency mechanism to ensure the fleet stays where the demand actually is.
Yeah, it keeps the ecosystem healthy.
So you have the customer, the kitchen, and the driver. Who is the air traffic controller making sure these three don't crash into each other?
That is the fourth and final component, the admin panel.
The brain.
The central brain, exactly. This is a massive, web-based dashboard accessible only to the platform owner. It doesn't live on a phone, it lives on a desktop. This is where you monitor the lifeblood of the operation.
Here's where it gets really interesting.
It does. You oversee user accounts, you verify restaurant onboarding, resolve payment disputes, manage the dispatch logic, and analyze real-time heat maps of where orders are surging.
It is wild that you can just license this entire 4-part control tower. But if I want to be the one sitting at that admin panel, we need to talk about the build and the bill. Like, what is the actual underlying technology making this real-time communication possible, and what is a real cost of entry here?
Well, the technology stack has to be incredibly robust to handle that level of concurrent data. For the front end, meaning the visual interfaces on the phones, developers utilize frameworks like React, Angular, or Vue.js.
Let's pause there for a second, because terms like React get thrown around a lot.
Sure.
But the reason they use component-based frameworks like React is critical for this specific business. It allows the app to update just one tiny part of your screen, like the real-time GPS location of your driver, moving down a map, without having to constantly refresh the entire screen where you might still be browsing a menu. It creates that seamless, native feel.
Exactly. It prevents the interface from feeling clunky or, web-based. Meanwhile, the backend, the invisible engine processing all the logic, is typically built on Node.js, Python, or Ruby.
And where does all this live?
All of this is hosted on scalable cloud services like Amazon Web Services or Google Cloud.
Which is the secret to surviving the Friday night dinner rush, right? Because cloud hosting allows the system to automatically spin up more server power when order volume spikes at, say, 6:30 p.m., and then scale back down at midnight so you aren't paying for server space you don't actually need.
It is pure elasticity. Combine that with external API integrations like Stripe or PayPal to securely handle the money, and you have a very modern tech stack.
Okay, so what's the damage?
As for the cost, the variance is staggering. The data indicates that if you utilize freelance developers, particularly in regions like India, you can acquire a basic, functioning 4-app clone ecosystem for around $8,000.
Wait, really? $8,000?
Yeah.
And you can barely buy a used heart for that, and here it buys you the foundational technology to rival a corporate giant.
True. But if you engage a large US-based development agency for a highly polished, fully custom version with post-launch support and complex feature integrations, you're easily looking at $300,000 or more.
Okay, let's step back for a reality check then. Because if the barrier to entry is genuinely as low as an $8,000 freelance project, why isn't every tech-savvy person listening to this right now running a global food empire from their basement?
Well, if we connect this to the bigger picture, it's because the technology is merely the vehicle. Acquiring the software does not mean you have acquired a business. The real barrier to entry is operational execution.
Meaning the day-to-day grind.
Exactly. First, you have the chicken and egg problem of building a restaurant network. A customer won't use your app if there are no restaurants, and a restaurant won't join your app if there are no customers.
Right. And even if you solve that, you are handling thousands of credit card numbers, home addresses, gate codes. The data security and privacy compliance alone is a full-time job.
Oh, it's a nightmare. Furthermore, you are stepping onto a battlefield populated by apex predators.
Oh yeah, the giants.
Right. If you launch a generic delivery app in Mumbai, you are fighting Swiggy and Zomato. In the U.S., you are fighting Uber Eats and DoorDash. These giants possess billions in venture capital, endless marketing budgets, and insurmountable network effects.
So if you try to fight them head-on in a major metropolitan area with an $8,000 clone app,
You will simply evaporate.
you are bringing a digital butter knife to a tank fight.
Very much so.
Which brings us to the most practical part of our deep dive. The only way to survive, let alone win, is to avoid the head-on collision entirely. You have to find a hyper-specific niche. And the sources provide a brilliant case study on this with a startup called Easy Eats.
Yes, Easy Eats is a phenomenal example of strategic market entry. The founders were college students who looked at Uber Eats and Grubhub and realized those massive platforms were fundamentally flawed when it came to servicing college campuses.
I know exactly what they saw, because think about the friction for a normal Uber Eats driver. They navigate to a massive, locked freshman dorm building. They don't have the security codes. They can't find the specific room in this labyrinth of hallways.
And the parking is always terrible.
Exactly. And the student ordering the food often doesn't have a lot of disposable income for a massive delivery fee. The global algorithm just wasn't designed for that specific geography.
So the founders of Easy Eats utilized what we might call geo-arbitrage. They partnered with a tech provider named Enatega to build a custom clone solution. But they geo-fenced their operations strictly to the college campus.
You just ignored the rest of the city.
They didn't care about the rest of the city. More importantly, they recruited fellow students to be the delivery drivers.
Which instantly solves the friction. Because a student driver already has the key card to the building. They already know that dorm room 402 is actually in the basement of the north wing.
Right.
The giant competitors literally cannot match that level of local access.
And they innovated on the software side as well. Knowing that college students are price sensitive, they implemented a group ordering function.
Oh, that's smart.
Yeah, an entire floor of a dorm could combine their individual orders from one restaurant into a single transaction, splitting the delivery fee. The app's integrated wallet system automatically handled the complex math of splitting the bill among 5 different users seamlessly.
So they took the clone app framework and surgically altered it for one hyper-specific demographic. And it paid off, right?
It really did. They pitched this student-centric model at the Greenlight Main competition, won $25,000 in funding, and successfully launched almost immediately beginning expansion protocols for other universities.
Wow.
They won because they solved a local problem that a global algorithm couldn't even perceive. And there are other examples in the data, too.
Like what?
Well, each sure used a similar framework, but abandoned standard restaurant delivery entirely, focusing exclusively on fresh, gourmet, healthy meal plan subscriptions.
Oh, a totally different model.
Yeah. Even Zomato differentiates itself from Swiggy by offering highly robust table reservation systems, basically transforming from just a delivery app into a comprehensive dining ecosystem.
It proves that the clone app removes the massive technical barrier, but it doesn't remove the need for genuine business innovation, which is a really empowering thought for you listening right now. Like, what is the unique friction in your specific community that the billion-dollar apps are completely ignoring?
There's always a blind spot.
Is it late-night bakery runs? Is it farm-to-table grocery delivery for a single neighborhood? The technology is literally sitting on a shelf waiting for you to plug a good idea into it. So what does this all mean?
Wow.
We started today looking at a nearly $2 trillion industry, right? And discovered that the blueprint to access it isn't locked in a Silicon Valley vault. We explored how these white-label clone scripts replicate the psychology of commerce, and we broke down the 4-app control tower that manages the delicate dance between the customer, the kitchen, and the driver.
Right, the symphony.
Yeah, and we looked at the scalable cloud technology making it possible, the stark reality of operational costs, and finally, how a strategy of geo-arbitrage like we saw with Easy Eats can turn an accessible piece of software into a highly defensible business.
It is a remarkable democratization of e-commerce infrastructure. But as we wrap up, I want to leave you with one final implication, drawn directly from how Swiggy manages its own data.
Okay, what is it?
The sources highlight that Swiggy's algorithm doesn't just passively process incoming orders, it aggressively utilizes historical data for demand forecasting.
What does that actually look like in practice, though?
It means the platform analyzes seasonality, micro-weather patterns, the time of day, and historical neighborhood trends to predict what people are going to order before they actually open the app.
That is wild.
They use this data to ensure their partner restaurants are properly stocked for a surge they don't even know is coming. Now, consider the trajectory of technology here. As these white label clone apps become cheaper, more sophisticated, and more heavily integrated with artificial intelligence, what happens when every single local startup has access to that caliber of predictive analytics?
Oh, wow. Will the local neighborhood bakeries app know you are craving a croissant on a rainy Tuesday before you've even realized it yourself?
It's very possible.
That is a fascinating and honestly slightly terrifying level of efficiency to think about. Thank you so much for joining us on this deep dive. Keep questioning the mechanics behind the technology you use every single day, and we will catch you next time.